As the Queen sent electricity into the national grid, what the watching public didn't know was the new reactor hadn't been built just to make electricity.
I believe there were times when it was taking electricity out of the grid rather than pumping it in. It's always been a cover, to some extent, for plutonium production. It took the edge off the destructive aspects of the bomb, which the government regards as good propaganda. We're doing this because it's going to be positively good for the people. We're not going to blow them all up. We're going to get some electricity out of it.
Secretly, Calder Hall was helping Windscale produce more of the material it needed to meet the demands of the bomb programme.
Britain had got to make its mark, and the way to make its mark was not to build a nuclear power station, but to let an H-bomb set.
As the world fated Calder Hall, Windscale was creaking under the new demands for the H-bomb. The more modern Calder Hall was a closed system and couldn't blow radioactivity into the atmosphere. But readings taken around Windscale had produced alarming results. Frank Leslie, a Windscale research scientist, discovered high levels of radioactivity around Seascale. Some of the radioactive cartridges had got stuck. They'd become lodged in the back of the reactor, bursting open. The famous filters, Cockcroft's Follies, had failed to prevent the radioactive dust being blown out over Cumbria. But Leslie's warnings were kept quiet.
Though it was known at the highest political levels, somebody up there also said it was to be kept secret. And that had very unfortunate repercussions because, again, for reasons I don't know, people in the research laboratories at Windscale were not allowed to know about it.
Then Britain's H-bomb project was hit by a new deadline. World leaders had met in Geneva to sign up to a ban on nuclear bomb testing by 1958. Churchill knew that Britain was running out of time.
It had to be hurried because of the nuclear test ban treaty. So there was that rather narrow moment of opportunity between us actually hitting the ground, not running very fast, in fact, barely walking, and the moment when it would come into force.
There could be no delays at Windscale. The leaking cartridges were dealt with by Moore, make do and mend.
People such as myself, ready in the bottom of the chimney, would go along the duct with a sort of shovel and push them back into the water duct so that there was no chance they would lie there and oxidize. So that helped to reduce the problem.
Vic Goodwin was a 20-year-old physics graduate who'd just arrived at Windscale.
Looking rather like a super version of a plastic Macintosh is a new suit designed for workers at Britain's atomic plants.
New recruits did get that kind of job. One wore a kind of polythene suit. I think one had an airline.
Once you're inside and the zip's been fastened, all that remains is to pump in compressed air so that the wearer can breathe easily.
One certainly had a rope round one's waist and a minder. That was a very reliable man who would make sure that you didn't spend too long or fall over into the canal.
It wasn't just unpleasant work, it was dangerous.
You had to strip off as soon as you got there and put factory clothing on, and then on the way home you all had to shower, and then you could go right through and then collect your clothes at the other end and come back in the clothes you went in. But you never wore your outdoor clothes on the factory, completely from head to toe. They were even vests and underpants and socks and shoes. Oh, he got scrubbed in the showers and he came home with bandages on.
The radiation dosage that we're allowed to take then was much higher than it is today. In fact, I think if we took the same kind of dosages today, there'd be questions asked in the Houses of Parliament. But that was life then, you know.
But with a test ban looming, the politicians couldn't afford any more delays.
Unless we do this very quickly, unless we achieve this research breakthrough in hydrogen weapons, then there will be a moratorium. There will be an end of fissile production. There will be a disarmament program, which the Americans and the Russians had signed up to, and we would be left behind.
If the test failed, it could spell the end of British hopes for nuclear collaboration with America.
So we had to go straight from the design principles to engineering it, to putting it in a bomber.
It was vital that Windscale make the deadline and deliver Penny the new material, tritium. It was a mountain for Windscale to climb. America's Atomic Energy Commission devoted huge resources to this task.
The Atomic Energy Commission controlled more assets and capital investment and scale of factories and so forth than the 6 largest United States corporations combined, used something like 1/10 of all the electricity in the United States, and so on and so on. It was a truly monumental effort to make these very small amounts of material with these extraordinary properties.
And Windscale was venturing into unknown scientific territory. New cartridges were designed containing enriched uranium and lithium magnesium, which could catch fire at high temperatures. Some of the senior scientists sounded the alarm.
They were putting things in which didn't look very nice from a safety point of view.
The pressure was such that, and people accepted pressures then, if a production target had to be met, it was rather like wartime, you met it.
They were running much too near the precipice.
But the warning signs couldn't have come at a worse time for the government. Britain's failed attempt to win back control of the Suez Canal had been a national humiliation. The American President Eisenhower had refused to back the British action.
Suez is undoubtedly the lowest point in the post-war special relationship with the United States. The United States effectively causes the withdrawal of Britain from the Suez operation itself.
Britain's new Prime Minister, Harold Macmillan, was not prepared to accept that the debacle in Suez was proof that Britain was no longer a great power.
Every now and again since the war, I've heard people say, isn't Britain only a second or third class power now? Isn't she on the way out? What nonsense. This is a great country, so don't let's be ashamed to say so.
Macmillan was convinced he could deliver what he called the Great Prize because of his friendship with the American president.
They'd had a very close wartime relationship in North Africa. They'd remained friends during the post-war period. They knew each other very well. They trusted each other.
In March 1957, Macmillan met Eisenhower in Bermuda.
He felt, I think, that his relationship with Eisenhower was so close, the trust was so great, that he could deliver what no other British Prime Minister had been able to deliver.
Macmillan urged his friend to convince Congress to share their nuclear secrets. But he knew that Britain would have to prove it was America's nuclear equal. America's H-bomb had produced a blast of a megaton, 10 times the size of Britain's atom bomb. Britain's H-bomb needed to be a megaton.
Somewhere along the line, the magic megaton had been mentioned.
A vast military force gathered in the Pacific for the H-bomb tests. The stakes for Penny had never been higher.
The tests in May and June 1957 are politically very important indeed, because there's this pressure for a moratorium on nuclear testing. The politicians really see an opportunity during this period to influence the Americans.